Hello world. I'm CJ, and this is a talk on QA testing strategies and how Cypress can help us meet our automation goals. As developers, we think of problems from a developer's mindset, which is packed with this advanced knowledge of software systems. What I appreciate about end-to-end testing is it goes back to the user's vantage point and centers that beginner's mindset. Incorporating both kinds of perspectives is really valuable in creating an optimized user experience. So to kick things off, I wanted to share a little bit about my tech journey. So I have a non-traditional tech background. I studied film history, then worked as a sound engineer before switching to tech. Within tech space, I used that humanities background in tech support roles where I specialized in API questions. From there, I worked as a full stack engineer for several years, and for the past year, I've worked as a quality assurance engineer for an e-commerce company. I mention my background because I do see parallels with sound and software engineering. The host of a radio show was kind of similar to a product manager in that they provided the content, and sound operators were similar to software engineers in terms of using the tools around them to make sure things worked as expected. We definitely adjust on the fly if there was something that unexpected happened, ticks like fuzzy audio. And as a sound engineer, I'd start my shift with these necessary checks on equipment to make sure it was operating properly. I do see a similar mindset with that and software engineering. Whether it's unit testing or end-to-end testing, devs definitely want those checks in place and to see the warning signs in order to fix them. Test engineering is all about figuring out how to optimize those checks and to see those warning signs and have the opportunity to correct them before they go wrong. So before I dive into Cypress, I did want to comment a little bit on testing philosophy from a QA perspective and how that shapes the automation that we build. If I were to summarize QA in a sentence, it would be this: the process of identifying defects and bugs in web apps in order to create a better user experience. I understand a defect to be something like a change introduced that doesn't meet requirements. And if it's caught in QA, a dev can immediately work on it. A bug is a problem in the code that makes it fail or act in unexpected ways. Bugs often take longer to address since they're often legacy code and introduced at an unknown or unspecified time. In ideal scenarios, we catch these bugs and defects in a staging environment and before they make it to production. In engineering, we talk about state a lot. And in test engineering, we hope for a state where no errors appear or errors do appear, but then they are properly detected. What's also key to this is a deployed environment that has services set up in a way that we might miss if we just use localhost. So in popular developer discourse, manual QA often means breaking things. And I grew up as a big Muppets fan, so I'm going to use the Muppets as an allegory for the QA process. Now, QA is sometimes represented by the figure of Animal here on the left. Animal takes objects and destroys them, and some might see that as a way to describe QA, especially manual testing. Manual testing is almost entirely UI focused. You go through a specific workflow like a checkout process, and you use your dev tools to spot a 404 or a 500 status code, and that usually determines whether or not something passes. The challenge in this approach is that bug detection can be really subjective. It's also really time-consuming in figuring out whether something is a legacy bug or a current bug. So while Animal comes to stand in for QA, I see myself more as Beaker or Bunsen here on the right of this slide, where I use story requirements, codes, and the tools available to me to either pass or not pass a project. I spend most of my workday running PR apps through an automated Cypress test suite that took a few months to build out. Since there are always new features, we're always creating new tests and thinking of new ways to speed up performance. Manual QA and exploratory QA are really crucial, and what makes automation really central to quality engineering is the time saved in identifying these red flags. We have output assertions that weren't met, and through this output, we're able to see where exactly in the app there's trouble and there needs to be some kind of remedy applied. So the manual aspect of QAing is reduced with automation, but not eliminated because there are always edge cases that are really difficult to replicate. I did want to give a hat tip to apps like Applitools that are doing amazing work using machine learning to catch these really subtle UI changes that historically have been the bread and butter of manual QA. Now, I've been part of companies that have QA teams who specialize, and that's really like an ideal scenario. And I've also been part of teams without formal QA, but who do QA work. And this latter situation is more challenging because it requires a dev to wear many different hats. And that's where I want to dig into testing types more. Bam. Because I've had different roles, I have noticed the approach to testing really vary depending on the tech focus that you have. Specifically front end or back end training. And we're going to start off with unit tests. So they're often about testing functions or methods, and they can technically work but still cause complications within your code base. Unit testing is very much guided by the question, does this method, does this function work? Whereas QA also asks, did it do what we expected it to do? And are there end results that we didn't anticipate? And maybe they don't cause problems now, but could they cause problems down the line? Integration tests are all about making sure the individual pieces of your app work together. For example, you might want to use an integration test to see that your app adapts to a new API change. Integration tests are important, and because they test these different parts of the app, they can often run slower than unit tests. Now, end-to-end testing focuses on making sure your entire app is working from the perspective of the user. In this case, we're testing for the user experience rather than the underlying code, and that it works as intended rather than just works. And how Cypress approaches end-to-end testing is going to be the focus of the rest of this talk. So I wanted to share a few lessons that I've learned in my time using Cypress. First off, access controls are helpful in determining which tests you write. Whatever your environment, you'll likely have users in different kinds of roles. In an e-commerce app, that might be a customer who's buying items, but there also might be an admin role whose behavior you definitely want to account for. It might help to focus on those specific roles that are especially important to you and then branch out from there. You'll also want to identify your most critical routes. For me, I let the nav bar guide me, guide which endpoints to cover, and through that, you might be able to identify which sections become the center of your testing process. So the e-commerce apps I've worked with, the checkout and cart workflows definitely structured our first series of tests. We focused on what could cause possible payments to fail. We did checks for invalid fields and whatnot. And within Cypress, and perhaps even front-end work in general, I definitely recommend trailing slashes in a URL. This is meant to reduce the number of 3.0 run redirects we put a user through in order to save them time. So now a kind of concrete use case. This is a sample file of a Cypress test that I worked on, and it has very simple assertions. From other testing frameworks, you might be familiar with this kind of structure. It uses a describe statement to group tests by themes and also uses it blocks for individual tests. Now, it's a fact of dev life that CSS selectors frequently change. I definitely recommend using constants globally as a way to make these edits easier. You'll notice I use the same selector on lines 12, 18, and 19. And I've encountered scenarios where selectors change and I had to individually update them line by line. So you'll definitely want to save yourself time by using constants globally. That way you can clean things up with just a few lines. So next up is a slide that shows my quick refactor up there on top of the file. In both examples, the test passed and it didn't negatively impact the speed of our suite. And to kind of show you that in action, on this slide, we have 3 passing tests that were completed in 50 milliseconds. And this is before the change. And now after the change, after our refactor, the test was completed in 49 milliseconds, so even sped it up slightly. Now some Cypress don'ts. Heads up that side.wait slows down your testing suite significantly. There is one case where I found the use of side.wait to be unavoidable, and that's in interactions with iframes. I've used side.wait very infrequently other than that. and definitely not beyond iframes. So just wanted to indicate a word of caution there. So now we'll transition from don'ts to do's. I definitely recommend the command scroll into view. A common error I encountered was an element existing on a page, but Cypress somehow not detecting it. That might have been related to viewport size, but whatever the cause, I found scroll into view to be really effective and have often used it in conjunction with the click action. And I found it to be really, really effective. Stubbing with data fixtures can also really help cover many of those test cases as possible. If you're interested more in changes of state with data, there's a really popular Cypress to Rails gem that I recommend. And in general, I definitely recommend utilizing Cypress dev dependencies, especially testing library is a very strong one. And there's also a really nifty Cypress retry plugin. And I think it's especially helpful from a CI perspective. Testing frameworks aren't perfect, and sometimes even the time of day might impact the speed of your tests and even whether or not the tests fail. So that particular retry plugin really helps to work around maybe a minor blip in order to get your tests passing. Also encourage folks to refactor scigget when possible. I found myself getting to the habit of using scigget so much, and then after grabbing a selector, I do an action and follow that kind of outline, and I'd be doing a lot of chaining of commands, and that habit really prevented me from seeing other more granular actions out there. Sci.findByTestID is a really effective command, and it involves a lot less chaining. It's a more readable action too. I also have one tip that goes in the it depends category, and that's use of page objects. So Cypress doesn't recommend use of page objects, but I found it useful. The support commands folder is typically where you put your customized commands, and page objects are basically namespace functions, and they really help me with readability. You can create your subfolders and tell what page they're for because you design them yourself. And I believe, yeah, that's my spiel on testing and Cypress. And here on the last side is where you can reach me here on Twitter if you have any follow-up questions or comments. And other than that, thank you for listening.